Welcome. I'd like to talk to you about factoring quadratic expressions a little bit more, and we're going to be factoring what are referred to as special quadratic expressions. There are a couple types of special quadratic expressions that we're going to learn. What I'm going to be talking about today is how you factor what are referred to as perfect square trinomials. Now, I'll teach you what a perfect square trinomial is pretty quickly. What I want to begin with, though, is doing what's called squaring a binomial. And simply, squaring a binomial is when you have a binomial and you square it. All right, raise it to the second power. Pretty simple thing. And what I want us to pay attention to as we square these binomials are some patterns that occur. Now, we'll come back to these binomials momentarily, but what I want to do first is kind of show you a generic binomial and show you what happens when you square it. So let's take a look at this. Suppose I was just simply squaring the binomial a plus b squared. All right, well, I want to get you past the part where you have to do what I'm going to do right now, but really, when you square a plus b, it means you're multiplying a plus b times a plus b. Okay, now I'm going to tell you that almost everybody who makes a mistake with squaring a binomial makes this assumption right here. They assume that when they're squaring a plus b, that the result is simply going to be a squared plus b squared, which is partially true, but that's not the entire thing. And you'll see that that's not the entire thing whenever you actually multiply a plus b times a plus b. Now, certainly, you are going to be, if you use the double distributive properties I've taught you in the past, you are going to be multiplying a times a, and so you get an a squared, but you're also going to have to multiply a times b. And when you multiply a times b, you're going to get an ab. So that is often left out of this product when people attempt it. And then whenever we distribute with the b from that first binomial, we have to multiply b times a, and that's going to give us another ab, right? B times a times b are the same thing, so we'll get plus another ab. And then, of course, finally, you do multiply b times b and get b squared, but you don't simply get a squared plus b squared. You get a squared plus b squared, and then you end up multiplying these two numbers together twice. We had a times b two different times, didn't we? And so in the middle, when we collect our like terms, we end up with a squared plus 2ab plus b squared. And this is what I'm wanting you to notice then. First of all, whenever you square a binomial, the result is always going to be a trinomial. And remember what it is that we're trying to factor in this video? Perfect square trinomials. That's called a perfect square trinomial. And a perfect square trinomial is simply the result of squaring a binomial. And there was a pattern that we could have used to go directly from where we were squaring the binomial to the final answer. All right. Now, part of that pattern is exactly what you'd expect. If you're squaring a plus b, yeah, you're going to square the first number and get an a squared. You're going to square the last number and get a b squared. But also, as you can see from our work, you end up multiplying these two numbers a and b together, and then you do that twice. So you get a 2ab. So the middle term always is a result of multiplying these two numbers together and doubling it. Now, this is a pattern that you need to know what the square of a plus b is. That's called the square of a sum. And then also there's the related square of a difference pattern where you have a minus b squared. And when you square a minus b, you're still going to get an a squared plus a b squared like you would expect. But as you can see from above, what we're also going to end up doing is multiplying a times negative b twice, so you get a minus 2ab in the middle. All right, you need to know these patterns here. Now let's apply that pattern to each of these binomials that we're squaring. Very simple. I'm going to square x plus 6, and the way I'll do that is I'll square the first number, x, so I'll get x squared. I'll square the last number, 6, and 6 squared gives me 36. And then to get the middle term of my perfect square trinomial, I'll multiply these two things together and double it. X times 6 is 6x. If I double 6x, I get 12x. That goes in the middle. You can check by using the double distributive property, multiplying x plus 6 times x plus 6 if you like. All right. Of course, if you remember the rules for factoring trinomials, it's quite clear to see this works because the factors of 36 that add up to 12 would be 6 and 6, wouldn't they? There we go. All right, so part B then. Squaring a binomial, we'll square the first term, get x squared. We'll square the negative 11 and get 121 at the end. And in the middle, we multiply these two numbers together and double. X times negative 11 is negative 11x. In the middle, we're going to get negative 22x. All right, just a couple of quick ones here then. I want to show you what happens when the first term is not just a 1x. And it's the same pattern though. Here we're going to square the 7x and get 49x squared. We'll square 1 and get 1. And then we'll multiply the two terms together and double. 7x times 1 is 7x. If you double 7x, you get 14x. There's your perfect square trinomial. And finally, 12x minus 5 squared. Well, square the 12x, you get 144x squared. Square the negative 5, you get a plus 25. 12x times negative 5 is negative 60x. And if you double that, you get negative 120x. That's how you square binomials. And now what we're going to do is the opposite. I just showed you how to square a binomial and to get a perfect square trinomial. Now what I'm going to do is show you how you take a perfect square trinomial and factor it into a binomial squared. So factoring perfect square trinomials. Now that means we're either factoring something in the form a squared plus 2ab plus b squared, or we're factoring something in the form a squared minus 2ab plus b squared, like what we looked at earlier in the video. Okay, now my directions for these examples say that we're going to determine, first of all, whether the trinomial is a perfect square, and if it is, we're going to write it in factored form. And the way I'm going to teach you to do that is simply this. Whenever you're trying to identify whether a trinomial is a perfect square, you begin by noticing the first and the last terms in the trinomial. And you see if they're perfect squares. X squared is a perfect square, 36 is a perfect square. And let's just say, for the sake of making this easy, that if those first and last terms appear to be perfect squares, we're going to factor as if this was a perfect square trinomial. And the way you would do that is this. Take the square root of each of those numbers, and those are the first and the last terms in your binomial. So you take the square root of x squared, you get x. Take the square root of 36, you get 6. And then you want to always keep the sign of this middle term right here, minus 6, and you want to say x squared. And then we're going to double check, because you know how to square a binomial, so you know whether this binomial would actually give you this when you square it. Now, if you square the first term, yeah, you get x squared. Square the last term, yeah, you get 36. And then the most important thing is, if you multiply these two terms together, and then you double, does it give you this middle term? X times negative 6 is negative 6x. If you double that, it's negative 12x. Voila, that's a perfect square trinomial, and we have factored it. So let's try that with part B then. This passes the first part of the perfect square trinomial test. I should have written yes for the last one, shouldn't I? Yes, it was a perfect square trinomial, and then there was the factored form. And now we want to see, is this a perfect square trinomial? Well, the first term is a perfect square, and the last term is a perfect square. So I'm going to go ahead and factor this as if it was a perfect square trinomial by simply taking the square root of the first and the last terms, as I was saying before, and then using the sign of this middle term right there, so plus 12. Okay, and then I'm going to check and see this. Again, is the first term squared going to match up here? Yes. 12 squared is 144. When I multiply these two numbers together and double it, do I get 12x? No. X times 12 is 12x. If this were a perfect square trinomial, this would need to be a 24x right there, and it's not. So this is not a perfect square trinomial. I'm going to go ahead and X this out, and we'll just say no, not a perfect square trinomial. Make sense? All right, couple more to try. All right, for 4x squared and 81, those are both perfect squares. Now the square root of 4x is 2x. The square root of 81 is 9. And this is a minus for the middle term, so I'm going to put minus here, and we'll put squared. And then let's see if it matches up. We already know we've got the two numbers that will match up with the first and last term for our trinomial. What's 2x times negative 9? Well, that's negative 18x. And if you double negative 18x, you get negative 36x. All right, that's a check. That's a yes. And we've already factored the trinomial. See how easy it is to factor the perfect squares? All right, it's not really that bad at all. All right, one more to do here. So, 49x squared plus 14x plus 1. Well, 49x squared and 1 are both perfect squares. So we get 7x and 1, and we'll put an addition sign in the middle to match that, squared. And then the middle term, 7x times 1 is 7x, and if you double it, you get 14x. So yes, that's a perfect square trinomial. And you got the pattern for factoring perfect square trinomials. Really simple thing to do. All right, thanks for your attention, guys. Hope you will pay attention when you have perfect square trinomials, because knowing this special pattern is going to make your life a lot easier for a lot of things that you're going to do with quadratics. Later.